Hi, good morning. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, in our video lecture series, we are going to discuss the topic Basic RC Circuits. This topic comes under the Transient Resonance in RLC Circuit, Unit 2. Come, let's get into the topic. So, an RC circuit is a circuit with both resistor and capacitor. They are common element in electronic devices and play an important role in the transmission of electrical signals. RC circuits are used as audio filters, electronic timers, oscillators, and more in a wide range of electronics projects. So this is actually a RC circuit, RC, which is connected in series manner. So this is nothing but a battery or voltage source. So a capacitor, how this RC circuit works. So first thing, before seeing the RC circuit working operations, we must know what is the capacitor process. So the capacitor can store energy and resistor placed in a series with it. It will control the rate at which it charge or discharge. This produces a characteristic timing dependence and crucial parameter that describes the capacitor's rate of charge and discharge. Tc, which is equal to R into C. That means Tc is a time constant of the capacitor in seconds. Next, R is the resistance of the circuit in ohms. And C is the capacitance of the capacitor in farad. So this is the formula Tc equal to R into C. So you just look at this circuit diagram where it has 10 voltage source, one switch is there, and R1 in 100 kilo ohm, and one ammeter and voltmeter is there, and one capacitor which has the value of 47 microfarad. So here in this case, when a switch is closed, current will flow into the capacitor. As the voltage on the capacitor rises, the difference in the voltage between the capacitor and the battery decreases. So the capacitor charging current tapers off as the voltage, the capacitor reaches the voltage of the battery, the capacitor charging slows down. The rate of charge and discharge of a capacitor in an RC circuit is described by the time constant Tc. And the time constant is defined as the time it takes the voltage across the capacitor to reach 60 to 63.2 percentage supply voltage. That is maximum voltage. That is time constant. It's a very important two more question. It's a time constant. So you look at the graph where T is x-axis is represented by the time period and y-axis is voltage. So where 63.2 percentage is attained by means of T time period. So this is called a time constant. So if the capacitor in the circuit above were shorted to ground with a jumper wire, the voltage across the capacitor would decrease following a curve like this. So we can see the decaying in the capacitor charging. So this is decreasing in the charging. That's a discharging. So this is the capacitor discharge. And if the capacitor in the circuit above were shorted to the ground with a jumper wire, the voltage across the capacitor would decrease the following curve like this. As an example, we will calculate the time it will take a 1000 microfarad capacitor to charge to 63.2 percentage of maximum with a 100k ohm resistor. So time constant which is equal to 0.01 farad. That is a microfarad means so we converted into farad into that 100 kilo ohms, okay, so which is equal to 100 seconds. So that means that the capacitor will take 100 seconds to charge. So this is called a time constant. And the uses of RC circuit. So the RC circuit which is used in wide areas. So in our daily life, that means the windshield wiper in our car. There is a wiper is there in front of the front mirror. That is a glass. When we are traveling in the rainy season, so to avoid the disturbance of the rain comes on the glasses, this wiper is used to swipe out the water falling on the glasses, right? So this is the mechanism behind this windshield wiper is also circuit. And the next one is the strobe lights. So the strobe light is nothing but of that's a very dim light, which is powered by the RC circuit. And the flash bulbs in the camera, old cameras, there is a flash bulb which is used to power the which is used to light up the environment, so that the photos we can take clearly. So in the olden days we used the flash bulbs in the camera. And some pacemakers, pacemaker we know, that is used to that will sense the electric pulse to normalize the heartbeat of the person. So the here the mechanism is the capacitor charges and discharges while regulating the heartbeat. That the main applications of the RC circuit in the pacemaker. And one more thing is, it is the charging and discharging capacitor charges is the cars turning light and traffic lights. So these are all the applications of the RC circuit.